We wanted to create something that makes gardening easier for everyone. The problem with most weed removal methods today is that they rely on harmful pesticides, or they're designed for large-scale farms and not small home gardens. Additionally, many automated systems only trim weeds instead of fully remove them at the root. We knew that we could do better. That's why we created the Auger, the autonomous weed and garden robot, designed to make garden maintenance effortless and precise.
In today's market, small-scale farmers looking to avoid chemicals face limited options. Existing methods come with major drawbacks. They're too expensive, too time-consuming, or not very effective. This presents a clear opportunity for innovation. That's where the Auger comes in. Designed to be affordable, efficient, and easy to use, the Auger reduces the labor needed for farm and garden maintenance while delivering better results. To ensure the Auger truly meets the needs of farmers, we engaged with potential users to gather feedback. Their responses were overwhelmingly positive, and based on their insights, we plan to enhance the Auger's functionality to include weed tracking and memory. With this feature, users will be able to identify the types of weeds in their fields, track where they grow most frequently, and predict seasonal weed growth patterns for better prevention. By equipping farmers with smarter insights and automation, the Auger makes sustainable farming easier and more effective than ever before. We designed the Auger with versatility in mind, one platform to meet a wide range of needs. Whether it's weeding lawns or gardens, aerating soil, or creating holes for planting, the Auger adapts to the task with ease. By incorporating a drill-like chuck, it supports multiple attachments, making it a powerful all-in-one solution for farm and garden maintenance. With its modular design and user-friendly interface, the Auger ensures that every function is accessible and efficient, allowing users to maximize productivity with minimal effort. Auger isn't just a tool, it's a smarter way to farm.
Safety is paramount when working with autonomous vehicles, especially those in open areas. And my team and I spared no expense on measures ensuring proper operation at all times the robot is active. Our robot uses automotive-grade parts to ensure all-terrain capabilities as well as safe operation within rough terrains. I also designed a completely fused power delivery system to ensure smooth operation of the robot as a whole, as well as keeping every single individual part within spec. There is a total kill switch mounted to the top of the robot for easy access, as well as an additional fused kill switch dedicated solely to the drivetrain. And each motor of Auger's weed removal system is connected to precise controllers so that the computer within the robot can control every single movement of that arm. As you can see, nothing in our design is left up to chance.
Another big portion to safety is the fact that we have a really large and heavy moving robot and potentially an unsupervised location. People or animals could be out in your garden, so it was really important to us to develop a good algorithm for object avoidance. For this, the Multiscan165 was kind of perfect for because it had multiple scan layers and its resolution was so good that we could detect objects from many meters away. For closer and smaller objects in direct path of the robot, an Intel RealSense was used. The combination of these two sensors together yielded something called the dynamic window approach to collision avoidance, and it is used in many autonomous vehicles, specifically due to it being so fast in unpredictable environments. Furthermore, the latter was absolutely essential in knowing where the robot was at any given moment. We didn't have a GPS or anything that kept track of location like that, so we needed to rely on the LiDAR points and the IMU to describe where we were in real time. This process is called SLAM, or simultaneous localization and mapping, and this is the way that we can tell exactly where the robot was so that we can get it to go where we want it to go.
We knew that for the robot to work effectively, we needed it to see weeds like a gardener would. That's where machine learning and artificial intelligence come in. We trained a neural network using hundreds of images of both common weeds and common garden plants. The model learned to recognize subtle differences in leaf shape, color, and texture, so it knows exactly what to keep and what to remove. To build the dataset, I started with an indoor bed of dandelions, because nothing could grow outdoors in Vermont this winter. By growing the dandelions indoors, I was able to collect consistent, high-quality images of the weeds at different stages of growth. So, even when they're in their earliest, most difficult to spot stages, the robot can still remove them before they take hold, making it more efficient and effective at keeping your garden maintenance low and simple. The AI processes real-time data from the robot's depth camera and compares what it sees to its trained network. If it spots a weed, The robot's auger will carefully remove it without damaging nearby plants.